Okay, here we go. All right, guys. Last week, I hope everyone at home and you are doing okay with this situation of this virus going on. Okay. Last week, this is the topic we were talking about. I can develop understanding. That is the same objective that is going to appear. These were the rules we mentioned. Be prepared, be patient, compromise. Turn your device to mute mode. Turn your video off at the beginning of every session. Raise your hand. Speak when the word is given and the deadlines. Remember? That's what we were talking about. This is the information that appeared in the website. You had some time to do CAN, CK's, Math is Fun, and that quiz. I saw a lot of you did most of that quiz, and you did really good in that. The idea of today's lesson and tomorrow, if you were able to check the video, is like to go around through the explanation and then go to the questions that you might have related with CAN and CK and Math is Fun, okay? Now, we were talking about transformations, okay? This is when Carol was able to read for us. And in a plane, you can slide, flip, turn, enlarge or reduce figures to create new figures. These corresponding figures are frequently designed into wallpaper, borders, mosaics, and artwork. Each figure that you see will correspond to another figure. These corresponding figures are formed using transformations. What is a transformation? A transformation maps an initial figure called the pre-image onto a final figure called an image. Below are some types of transformations. The red lines show some corresponding points. So this is what we're going to be talking about. Okay, so here you're going to be able to see translations, reflections, rotations, and dilatations. Okay, what is a translation? A figure can slide in any direction. So like when you're skating, you can slide more or less, right? That would be you can be slid in any direction. So here's the example. It moved to the right, or it can also move upward or to the left or in any direction, as it says over here. A reflection can be flipped over a line, right? So that's what happens when you go every morning and brush your teeth in your bathroom. You can see a reflection, right? That's why when you see through a mirror, most of the words, the letters change, they're reflected. A rotation is when a figure can be turned around a point, okay? So you had a rotation. A dilatation is a figure can be enlarged or reduced. So dilatation is like when you're working on your computer and you can zoom in or zoom out on your computer or on your cell phone or on your tablet, right? Any questions up to here? Guys? Any questions?
No.
No questions? Okay, great. Now, here are some exercises. Translation, remember what is reflection, what is a rotation, and what is dilatation. So for the first one, guys, what would the first one be?
Rotation.
Rotation,
Yes.
because a figure can be turned, around a point, right?
Yes.
Yes, okay. What about number two?
Dilation.
Dilatation.
Dilatation, very good. And number 3?
Reflection.
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 Reflection. Ay. Reflection. And number 4?
Translation.
You're having a translation. Yes, because it can slip in any direction. And number 5?
Dilation.
Dilation.
Dilation. Dilatation, guys. Dilatation. Give me a second, let me turn some internet things here in my computer that are making this presentation slower. Okay, here we go. So you said number 4 was going to be translation. Number 5, you said it was going to be dilatation. What about number 6?
Reflection.
Reflection.
It's going to be reflected under this point.
Yeah.
And number 7?
Translation.
Translation.
Number 8?
Reflection.
All right. Number 8, you said what? Reflection?
Yes.
Okay, what about number 9?
Reflection.
Reflection?
Yes.
Reflection. 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 Okay. And number 10?
German, I have a question for number 10.
Yes.
For example, in that one, I get confused. That is rotation or reflection?
Well, that's the idea. We can all answer in this moment what is happening here in number 10.
Translation.
Oh, so you can have translation. What else do you said, Mariana? Can you remind me what you said, please?
Reflection and rotation.
And rotation. Mr. Duque, you said translation?
I haven't said nothing.
No, I'm sorry. Okay. So we can have reflection or rotation. That's what Mariana is saying.
Translation.
What the in translation? Who said? Anyone said translation?
Me.
Okay, Carly. And translation. Translation. Reflection, rotation, translation. So let's go ahead and see the definition of reflection. A figure can be flipped over a line. So we can have this one. We will have the blue figure is the pre-image. So this is the pre-image, this is the pre-image. Yes? And here you have the green images. And look that here inside you have like a little green part. So you can have a reflection on the other side. Yes, I agree with what Mr. Carrizosa said. Rotation, a figure can be turned around a point. Yes, what happens if you rotate this figure 180 degrees in this direction? That would be a rotation. Yes, and a translation would be they were sliding like this, right? So I agree with Mr. Carrizosa and I agree with Maria Hincapié, and that means a figure can have different transformations, right? And depending on the shapes of the figures, like in this case of exercise 10, you will be able to identify different forms of transformations. Is that clear up to number 10, guys?
Yes.
Yes, no problem? Okay,
Yes.
let's move on. Where are reflections found in nature? Can anyone read this for me, please?
On a clear, bright day, lakes can provide vivid reflections of the surrounding vistas. Note that each point above the water line has a corresponding point in the image in the lake. The distance that a point lies above water line appears the same as the distance its image lies below the water.
Exactly. So this is like where if it was going to be like a mirror, right?
Mhm.
So that would be reflections. Okay, thank you. Let's move on. Draw reflections. Mr. Duque, can you give me a hand, please?
A reflection is a transformation representing a flip of a figure. Figures may be reflected in a point, a line, or a plane. The figure shows a reflection of A, B, C, D, and a line M. Note that the segment connecting a point and its image is perpendicular to a point and its image, to line M and is bisected by line M.
Bisected by line M. Okay, give me a second, give me a second. Let's check what's happening here. Are you able to see that the blue line is going to be making the image? The pre-image, I'm sorry, the pre-image is going to be made by the blue line. And the points where the blue line are is A, B, C, D, E. So you can see that's the figure it's being done. Now the reflection along line M, which is going to be the bisector, is the same distance as you're going to be measuring from point A to line M. Is going to be the same distance from that line to the new point, right? That's why you have all these dashed lines from all the different points. Can you continue, Mr. Duque, please?
Line M is called the line of reflection for A, B, C, D, E, and its image A, B, C, D, E, because E lies on the line reflection. Its pre-image and image are the same point.
Very good. So, Mr. Carrizosa, can you read here, please?
It is possible to reflect a pre-image in a point. In the figure below, polygon U, B, Y,
B,
Y, X, Y,
W,
C,
U, W.
W, X, Y, C,
Uh-huh.
and reflect point P.
Okay, so look, it's reflected within point P. So what you do is you have to measure here. It's not going to be as simple as this one, because here you had a line which made it easier. And now in this one here, you're going to be reflecting on a point. Okay, so when you measure it on a point, you will have to make like lines, long lines, continuing, that will give you the distances between the point P, where it's going to be reflected, and the new point where it's going to be located. Okay? Look, the distance between W and P is going to be the same distance over here. So it's like if I made a long line. Let's make it in black. Yeah.
So, German, one question.
Uh-huh.
So it doesn't matter the way that is reflected, as it's the same figure, it needs to have the same points.
Yes, it needs to have the same points. So look,
Okay.
okay, Martina?
Mm-hmm.
Right, so look, guys, it's a long line that I'm going to be reflecting. Now, I'm going to be reflecting this point B. So what I do is I make long lines from the points I want to be connecting. Yes? And then I will measure and find out that the same distance between the point W and the point P is going to be the same distance between the new W prime. Look that the line is exactly the same. And the distance between V and point P is going to be exactly the same as the distance between V and V prime. Okay?
Teacher, I have a question.
Yes, Salome.
Uh, only the points W and V needs to be equal. The rest, no, or
No,
everyone.
all the
or-
points,
oh.
all the points, yes. Look, the distance between Y and P is going to be the same distance between P and Y prime. So what I do is I make long lines, right? And then I measure this little distance between the point you're mentioning and the point mentioning and the new prime point, okay? They have to be the same,
Okay.
okay?
Yeah.
So note that P is the midpoint of each segment connecting a point with its image. So you can see that the segment UP is congruent with segment PU prime. That's what it means, it's congruent. Let me erase all these lines so it can be much clearer for you. Delete. And segment VP is going to be congruent with segment PB, okay? And the same happens with all the different segments. Any questions up to here, guys?
No.
No?
No.
Okay, let's move on then. When reflecting a figure in a line or in a point, the image is congruent to the pre-image. Yes, that's what we were saying over here. Segment UV was congruent to segment U prime, V prime. Segment UV was congruent to segment U prime, V prime. They have to be exactly the same, okay? The same happens with all the different segments you have over there. And let's see what happens with the angles. Angle UVW. Wait, sorry guys. Ah. So the angle UVW has to be congruent with angle U prime, V prime, W prime. Okay? UVW. let's color it in a different image so you can visualize it. U, V, W. This is what happens when you don't teach in a classroom every day. UVW is going to be the same as U prime, V prime, W prime.
Teacher, what means prime?
Prime?
Like, do
Yes.
you say like U prime, V prime, W prime? It
Yes.
is the ones that reflect.
Exactly. This is the pre-image. The green one is going to be the image. So U prime, V, V prime, W, W prime.
Okay.
Okay? That's what it means. This is the little things over here. These ones. This means prime. Pre-image, image. Okay? And the same happens with the angles because all of the segments were the same. Well, they need to make the same exact angles. Okay?
Okay.
Thus, a reflection is a congruence transformation or an isometry. Okay? That is a new word, isometry. That is, reflections preserve distance, angle measure, betweenness of points, and collinearity. In the figure above, polygon W, U, V, W, X, Y, Z is congruent to the other polygon. They are congruent. Yes? The same will happen over here. In polygon A, B, C, D, E, has to be congruent with A prime, B prime, C prime, D prime, and E prime. Look that the lines measure exactly the same. So if they measure exactly the same, and it's going to be the same distance from the line of reflection, okay, to the pre-image point, it's going to make the same angles. These angles have to measure exactly the same, okay? Any questions up to here, guys?
No, German.
Okay,
No.
remember you can download this presentation in MathRoots by through using the video or downloading the PDF presentation, okay guys? Okay, now reflecting a figure in a line. What I want you to do, guys, is I want you to take out a piece of paper and follow these instructions, okay? You can decide to draw the lines in the colors you want. I don't have a problem. And please show us your image using the webcam of your device, okay? Okay, guys?
Yes.
All right.
Yes.
German, sorry, you can explain again what we have to do.
Okay, what you have to do is you have to draw this reflected image.
Lo mismo.
Yes, do exactly the same that appears over here.
So, Mr. Mejia, we just draw the image that is there.
Yes, you just have to draw the same image that is over there.
Okay.
All right, guys, are you ready? When you're ready, the only thing you have to do is turn your video on and show us your image.
But wait.
Guys, you need to finish. Time is going to be up and the presentation is going to be closed in 3 minutes.
German,
Yes,
D is for both figures.
D, yes, because D is on top
Okay.
of the line of reflection. Look, it's exactly in that point.
Okay.
German, I think I finished.
Okay, can you
But
please
I
show?
don't know.
Can you please show your video?
But how?
Let me show you. You turn your video on exactly, and yes, there you are.
But
Very
I
good.
don't think you can see it.
Now,
I don't know if you managed to see it.
yes, I can see it. I can see. Let me do something over here. Let me see if I can maximize this. No, you know what? You know what we're gonna be doing, guys? I want you to please scan or take a picture of your image and send it through Phidias so I can publish them here in the presentation, okay?
Teacher, I finished, so we don't show to you.
No, because it's going to be difficult to see. What you're going to be doing is you're going to be scanning them and sending them through Phidias. Okay? That is going to be like what the homework is going to be assigned for you guys, because we're also going to be talking about reflection in the x-axis, because you already know what a reflection is. Now the line of reflection is going to be x. That's why you have k, for example, in this figure.
So I don't show you, Mr. Mejia.
No, because we can see, as I said before, Carol, and I need everyone concentrated. You're going to be taking a picture, or you're going to be scanning, and you're going to be sending it to my Phidias so I can publish it on the website. All right, guys? Now,
Also, we just
what?
send it by video.
Yes,
That's it.
that's it. You just send it through Phidias, because like Ms. Lopez just showed us, it's very difficult to identify the exact point. Now, for example, here in quadrilateral KLMN, you're gonna have you can have two different lines of reflection, but the question here says reflection in the x-axis. And when you have a reflection in the x-axis,
Wait, German, a moment. Can you like show again the image so I can take a picture?
remember, Maria Paula, you can have this in Math Rules. This presentation, exact presentation is in Math Rules, okay? So you can download it from over there. Now, guys, as I was saying before, the line of reflection in this exercise is going to be the x-axis, reflection in the x-axis, right? That's why the coordinates of point K that was going to be 2, 1, 2, 4, 1, 2, 3, 4 is going to be reflected, and the new location is going to be -1, -2, -3, and -4, right? Guys? So look, the blue line is the image, the pre-image, and the green line is going to be the image, okay? So these are the lines that appeared in CK12. Remember that you had some points and then you had this information? So what we're going to do, guys, is I'm going to assign you to please draw the following. I will upload the figures that you're going to be drawing, because tomorrow we're going to be meeting again, remember? So tomorrow, when the meeting is on, where we're going to be talking about the figures that you drew, we're going to be selecting some of them randomly, and we're going to discuss them, okay, guys?
So you're gonna show us which images we have to use, or
Yes.
what?
Yes, I am going to send them through Phidias. All right, guys?
Yes.
Okay, it's been nice sharing some time with you today. I have to leave because I have another class going on, and we'll see ourselves tomorrow. All right, guys?
Okay.
Bye, teacher.
guys.
Okay,
Thank
bye.
you.
Thank you very much. Bye-bye.
Bye, German.
Take
Bye,
care.
German.
Thank you,
Bye,
guys.
German.
Bye.
Bye, German.